sun's out, but are you really protected? One slip and UV rays can damage your skin. Let's uncover the science that keeps us safe and how sunscreen is actually made. Active UV blockers have two families: physical or mineral filters, which are micron-sized zinc oxide or titanium dioxide. They sit on the skin's surface and reflect or scatter UVB and UVA. Chemical or organic filters, such as oxybenzone, avobenzone, octocrylene, octinoxate, and so on. They absorb photons and convert them to heat via photolysis. The inactive matrix gives feel, spread, and stability, with emollients like dimethicone, jojoba oil, and caprylic or capric triglyceride. Thickeners like cetyl alcohol, carbomer, and silica. Emulsifiers like polysorbate 80, cetyaryl alcohol, and lecithin. Preservatives like phenoxyethanol and benzyl alcohol. Antioxidants like vitamin E, or tocopherol, and green tea extract. And additives like fragrance, colorants, and water-resistant polymers, for example, acrylate copolymers. Sourcing and purity. Ingredients must meet USP or ISO standards. Many manufacturers audit suppliers and run FTIR or HPLC tests to confirm identity and purity. For the oil phase, melt solid waxes, such as cetyl alcohol and stearic acid, with emollients at 70 to 80 degrees Celsius. Disperse UV filters, often pre-micronized to less than 200 nanometers to avoid a white cast. For the water phase, heat deionized water to the same temperature. Dissolve humectants, such as glycerin and propylene glycol, and water-soluble preservatives. For pH adjustment, bring the combined phases to pH 5.5 to 6.5, which is skin's natural acidity, using citric acid or sodium hydroxide. This stabilizes both filters and emulsifiers. For emulsion design, choose an oil and water system for most daily sunscreens, and water and oil for high SPF, water-resistant products. Batch size ranges from 500 liters to 5,000 liters in stainless steel jacketed tanks. A high shear mixer rotates at 2,000 to 4,000 RPM, creating turbulent flow that reduces particle size and ensures uniform dispersion of zinc oxide and titanium dioxide particles. Temperature control keeps the batch at 75 to 80 degrees Celsius during mixing, and cools to 45 to 50 degrees Celsius before adding heat-sensitive actives, for example, avobenzone, to prevent degradation. Vacuum degassing removes air bubbles that could cause splattering or affect SPF measurement. For two-phase addition, you want to slowly add the oil phase to the water phase while the mixer runs, and then you switch to a high-pressure homogenizer, something like 30 to 80 megapascals, to achieve droplet sizes less than 0.5 micrometers. The emulsifier's role, well, it's pretty crucial here. Polysorbate 80 and cetyryl alcohol form a viscoelastic film around the droplets, preventing coalescence. After homogenization, you rapidly chill the emulsion to somewhere between 25 to 30 degrees Celsius to lock in the microstructure. For in vitro SPF, you apply 2 mg per centimeter squared to a substrate, for example, PMMA plates, and measure transmittance with a spectrophotometer. Then, you calculate SPF using the ISO 24444 method. For broad spectrum, or UVA-PF, you use a similar measurement, but integrate UVA from 320 to 400 nanometers. You need a UVA-PF that's greater than or equal to 1/3 of the SPF. For photostability, you expose the product to 5 joules per centimeter squared of UV, and then remeasure the SPF. If the loss is greater than 20%, you add stabilizers, for example diethylhexyl 2,6-naphthalate. For water resistance, you apply the product to volunteers, have them swim for 40 minutes, and then remeasure the SPF. It must retain greater than or equal to 50% of the original SPF for a water-resistant claim. For microbial challenge, you inoculate with Staphylococcus aureus and Pseudomonas aeruginosa. The product must pass USP 61 after 28 days. You use stability chambers for 3 months at 40 degrees Celsius and 75% relative humidity, and 6 months at 25 degrees Celsius and 60% relative humidity. And throughout, you monitor viscosity, pH, and active concentration. A filling line uses sterile, nitrogen-purged pumps to fill PET or aluminum containers. Airless pumps are pretty common for high-end sunscreens to prevent oxidation. Sealing uses induction sealing for bottles and ultrasonic welding for tubes. The label content includes SPF rating, broad spectrum claim, water resistance, active ingredients, net weight, expiration date, batch number, and manufacturer contact. Regulatory compliance includes FDA in the USA, EU Cosmetic Regulation in the EU, and Health Canada. Each one requires pre-market notification or registration. Cold chain logistics maintain 15 to 25 degrees Celsius during transport to prevent phase separation. Eco-initiatives use post-consumer recycled plastic biodegradable packaging and reef-safe filters, with no oxybenzone or octanoxate. Carbon footprint tracking means many brands calculate CO2e per kilogram of product and offset via renewable energy credits. Sunscreen is honestly a marvel of chemistry and engineering. Tiny particles, precise emulsions, and rigorous testing all work together to shield our skin from the sun's invisible threat. Wear it, love it, and stay protected. Thanks for watching. Don't forget to like, subscribe, and share your sun-safe tips in the comments.